Welcome to Breadboarding. This is video 17 in the Breadboard 8088 PC series, and it's the fifth video in the monochrome display adapter part of the project. In the previous video, we installed quite a few of the chips that we've got here, the video RAM, CRTC, and the video digital analog converter. And in this video, we're going to be doing the test software and actually check to see if we can get any video output coming out of the board. So just have a look at the block diagram. So this is where we left things last time, and what we need to do now is to wire up the MDA board onto the main address bus, data bus, and then we also need to wire in a few of the I/O port decoder signals, so I/O read, I/O write, and we also need to make sure that the video RAM has the chip enable and the memory read write signal there as well. So we're just going to wire those in, and then we'll have a quick look at the test programs and see whether we can get any output. So let's take a look at the board. Now put it alongside the rest of the Nanocomp 8088. So we see here we've got our address lines here, we've got the data lines, and there are some additional wires we need to wire in. So we've got the I/O read write, we've also got the enable signal for the I/O A19 to A12, which needs to come from over here. We've also got the chip enable for the video RAM that needs to come over here, the read write, which comes from the memory write signal for the video RAM, but we also need to make sure we use the I/O ones for up here. I had made a little bit of confusion down here. I was using the read write signal for the CRTC, and it actually needs to be the I/O write. What I have also done is I've wired in the inputs to the video DAC to be driven from some of the memory address lines from the CRTC. So when we actually start to test this, we should actually have some signals to give us some video output. So I'm just going to wire this in. So we're going to need to wire in memory right up there, a couple over here, and wire in the address and the data bus here. Okay, so we're just going to plug in the data lines. Cables could be a bit shorter. Just need to tie the two boards together physically, and then putting in the reset and the E signals. I didn't quite put it in the right place, so just shuffle it down a bit. So that's the reset signal and then the E signal. Now I need to tie the read write on the CRTC to the I/O write line, which is also coming in on the I/O decoder up there. Now this is plugging the I/O read and I/O write going into the decoder. We'll tidy up those leads a bit later on. I need to do some tidying up in a couple of videos time. And this is the memory write signal going from the video RAM up to the top there. We may also need to do the memory read as well. I think I might have forgotten that one. And then this is putting in the address line. So we've got the A0 to A7 are in a block first of all, and then we've got the 8 and 9, and then finally 10 and 11. Okay, so that's all wired up, and I've also wired in the power connector at the top here up into the power distribution board there. So I'm just going to now plug in the video capture card here. This will allow us to see what output there is. So we should all be ready now to run it. I'm just going to now quickly go through the test software. So this is MDA test 1. So this one will be doing the white grey MDA values, and I'll explain why we're doing different versions of this. So we've got here is the I/O ports defined for the CRT address register, CRTC data register. Then this is the digital analog converter for the address write, the color value, pixel mask, and the address read register value as well. So those are very similar to the Nanocomp 6809 version that we were doing. So our program is very simple. We initialize some variables that we'll use when we need to start clearing screens and things. And what we do is to read the list of the 6845 CRTC values. So there's a table down here. So these are all the register values for the total number of characters across the screen, displayed characters, number of lines, sync positions, adjust various other things. So these are all the CRTC values. The base for these has come from the timing calculator here, which I included the URL in one of the earlier videos. And this basically will give you the starting register values that you need here. Needed to be tweaked slightly to work with the video capture card that I've got, but this is where the baseline register values came from here. So once we've initialized the CRTC registers, we've actually got values for the background black, the bright foreground and the bright background values. And what this basically just does is outputs to the video DAC. We're just hard coding this in this particular one. So we've got black, we've got the standard foreground color, which is 2A out of 3F. So the colors for the palette go from 0 to 63 or 0 to 3F in hexadecimal. So 2A is about 2/3 of the maximum intensity. This bright background is in fact about 1/3 intensity, and then the bright foreground is then full intensity. So we've basically got 3 colors here and black. And so basically all that does is initializes that. So once this is actually run, then we should then get to see something on the monitor or on the VGA capture card. And at the moment I've got the input values to the digital analog converter just tied to some of the address lines from the CRTC. So that should mean we'll get some sort of variation in the signals. So just going to download this to the Nanocomp. So I'm just going to switch on the Nanocomp and we're going to download our test program. So I've got MDA test 1SREC. I assembled this a little bit earlier. So I'm just going to put the Nanocomp on to load, send the file, so that's completed, and then when we run this, what we should find is that we get a pattern on the video capture card. So I'm just going to switch to the video capture card. Okay, so we can see here that on the VGA capture card we've got black, we've got the normal intensity foreground, we've got the high intensity background, and then we've got the high intensity foreground. So this is bright white, this is kind of dark grey, this is light grey. So those are the values that we would expect. Now I've actually got a couple of versions of this program. So the next version is actually doing shades of green rather than shades of white and grey. So this is MDA test 2, and this should come out in green. Yep, so this is showing us the different shades of green, and this is probably the closest thing to the original MDA monochrome display. And then one of the other things I have done as well is, because the MDA adapter was capable of outputting colour display, ironically given it's a monochrome name in the title, however IBM didn't actually release a colour monitor compatible with CGA until about 1983, and the original MDA was released in 1981, so it was actually about 2 years before there was a colour monitor from IBM capable of actually showing this. So what I'm just going to do is to hook up 2 extra address lines on to the memory addresses, and then I'm going to run the MDA test 3 and we'll see whether or not we can get the colours coming out of this. So just going to run that. And this is now showing the 16 CGA compatible colours that we should be able to get, and hopefully these will be pretty close to the original CGA colour set, and also includes some adjustments to allow for showing brown rather than dark yellow. So if we go back and explain about the colours, so this is from the original IBM documentation. You can see that there's red, green, blue values and an intensity. And so when we're looking at the MDA basically just has black, white as 111, and it also has a rather strange one that underline is 001. Now it's not shown on here, but basically the CGA colours are based on red, green, blue and an intensity. And so for MDA we were just using background colour intensity 0 and 1, and we had foreground colour intensity 0 and 1, and that gave us the 4 colours. Now these are the colours from the original CGA, but the only issue really here is that the brown, white and grey here were actually changed in the CGA colour set to be adjusted, and the actual CGA monitors actually included some electronic circuitry to actually adjust the values. And in fact this is a excerpt from the URL below here where this explanation is actually given. So this would be the colours as they would be expected to be normal, and you can see here that there's a dark yellow here and there's also a black here, but in fact the CGA colours, that the dark yellow was adjusted to be brown. So you can see here that the green value was reduced to the third of intensity rather than 2/3 intensity, and you can see also that for the dark grey here, that rather than being 000 for black, it was a third intensity as well. So the colours that we've got here are pretty close to this. The brown colour was not quite brown, it might need a little adjustment, but it certainly wasn't dark yellow. So looks like the colours when we need them coming out of here are looking good. So we've completed the video testing to initialise the CRTC registers and video DAC, and we've shown a couple of test patterns both with white, grey and with shades of green, and also showing the full CGA colour output that potentially could be produced from the monochrome display adapter if plugged into a compatible monitor. So in the next video what we're going to do is to add the character latch, the character generator, EPROM and the shift register, and that should allow us to output test characters out to the display. So rather than just the rather boring test pattern, we should be able to get the full character set coming out. And then if we have time, we'll also add the CRT status register and control register and the blink clock as well. So if you don't want to miss out on future videos, please hit subscribe, and if you found the content interesting and useful, please hit like. It just helps to make the videos available to a wider number of people. Thanks for watching.